Hi viewers, we want to look at linear expansion, which we can call it coefficient of linear expansion or expansivity, and the symbol is alpha. Now, when we say expansivity, is the increase in length per unit length of a substance for each degree Kelvin rise in temperature, and its unit is per Kelvin. Viewers, from this definition, we can say that expansivity is equal to expansion E, or divided by original length into bracket L1 times change in temperature. So we can shorten it as expansivity is equal to E, which is expansion, divided by original length L1 times change in temperature. Where we have expansion will be equal to final length, which is L2, minus original length, which is L1. And also change in temperature will be equal to final temperature minus initial temperature. When we name this equation 1 and we substitute this into equation 1, we are going to have expansivity equal to L2 minus L1, all divided by L1 multiplying change in temperature, theta 2 minus theta 1. All right. Now, from this, we can make L2 minus L1 the subject, where we say L2 minus L1 should be equal to alpha multiplying L1 multiplying theta 2 minus theta 1. Here we can be asked to find L2, which is final length. So L2 will be equal to L1 plus alpha multiplying L1, which is the original length, multiplying theta 2 minus theta 1. From this, we can factorize L1 out. So L1 out, we are going to have 1 plus alpha multiplying final temperature minus initial temperature. Even from this formula, we can also be asked to find change in temperature. So here we can say theta 2 minus theta 1 should be equal to L2 minus L1, all divided by alpha multiplying L1. Don't forget that we can be asked to find any of these quantities in this formula. In our next video, we are going to see how we can use these formulas to solve questions. Thank you. Hi viewers, the formulas that we studied in our previous meeting, let's see how we can use them to answer these questions on the board. Let us look at question number 1. From question number 1, we have been asked to calculate the expansion of 15 meters of copper pipe when heated from 5 degrees Celsius to 60 degrees Celsius. If the linear expansivity of copper is 0.00017 per Kelvin. Viewers, from the question, we are looking for expansion, which we don't know. And we have 15 meters of the copper pipe. So that represents our original length, which is L1, and we have 15 meters. Since the temperature is heated from 5 degrees Celsius to 60 degrees Celsius, it means that we have to find change in temperature. So our change in temperature will be equal to final temperature minus initial temperature. And our final temperature is 60, so we have 60 degrees Celsius minus 5 degrees Celsius, which is going to give us 55 degrees Celsius. Now, from the question, we have expansivity of copper, which is alpha, to be 0.00017 per Kelvin. Now, from the formulas that we studied that linear expansivity is equal to expansion all divided by original length times change in temperature. Now from this formula, we are looking for expansion, and we know our expansivity here. So we substitute the values into the formula, and we have 0.000017 should be equal to expansion divided by original length, which is 15, times change in temperature, which is 55. So we simplify this as 0.00017 equal to expansion 15 divided by 55 will give us 825. All right. Now at this level, we cross multiply to find our expansion. So we have 0.000017 times 825. All right. And when we multiply this, we are going to have 0.014025 meters. So this is how we can get our expansion. Use the same principle and the same concept to answer question number 2 and number 3, and leave your answer in the comment section. Thank you.